Okay, so this video will explain the mean value theorem. The mean value theorem is a way to relate the average rate of change of a function with the instantaneous rate of change, which are two concepts we've seen before. Average rate of change is where we take sort of the slope between 2 points, right? So we look at a function and we pick two values and we think about connecting those values with a straight line. And what would the slope of that line be? That would be the average rate of change. To give like a context for that, that would be like if you ran, 100 miles in, 20 hours, let's say. All right, so how fast did you run? Well, you did 100 divided by 20, right? You ran 5 miles per hour. Now, that doesn't mean you ran 5 miles or 5 miles per hour the whole time, right? This is your average rate of uh, change, your average velocity. But if you took like every speed that you were running and imagine averaging them together, your average speed was this. Okay. Instantaneous velocity, on the other hand, is what we've been talking about for a while now. That's just the derivative, right? So when we look at the slope of the tangent line at a point, right, we call that the instantaneous rate of change. But that's just f prime, right? Just like we've been doing. So the mean value theorem lets us relate the two concepts, and I'll just throw the theorem up here, and we can digest this thing. So, okay, the idea is we need a function to be continuous on the closed interval from a to b and differentiable on the open interval. What's really important is just the fact that it's differentiable on the interval, and we'll talk about that. The reason it needs to be continuous is because we need endpoints. We're gonna draw an average rate of change in a minute, so we actually need like an a and a b to exist. So that's why it needs to be continuous on the closed interval. All right, but the key thing is it's differentiable. So if that's true, then there has to be some x value that we'll call c in between a and b, so that the following statement is true. Okay, f prime of c is equal to f of b minus f of a over b minus a. Okay, so let's, try to figure this thing out. So this part we've seen before. It's been a while since we did this, but this is average rate of change. If we go back here for a minute, right? How do we find the slope of this line? Well, it's f of b minus f of a, right? All over b minus a. Well, they wrote a minus b, but same thing. Okay, so this part of the formula is just the average rate of change from a to b. And then f prime, right, is the derivative. So what it's saying, right, if we take a function and we connect 2 points, right, that would be our average rate. There needs to be some place in the interval from a to b where the tangent line, right, the derivative, is the same. Right, so like right about here would be our c. So this tangent line is the same slope as the average rate of change, right? Those lines are parallel. So the mean value theorem is just guaranteeing the existence of a particular slope in the interval. And again, it relates the average rate of change and the instantaneous. Okay, but then it always comes down to what do I need to know for the test? So, how is this going to be presented to you? It would be a question like this. Let f be x cubed. Find all the values of the constant c satisfying the conclusion of the mean value theorem on the interval from -1 to 1. So when you see a question with mean value theorem, what I recommend you do is write this thing down. Okay, so you probably just want to memorize this. Ideally, you'd understand it by the test, but memorization is the first step to understanding anything. Okay, so start by writing that down. And now plug in what you know. Okay, A and B are the endpoints of the interval. So like we're going to do f of 1 minus f of -1 all over 1 minus -1. Okay, so the bottom cleans up to 2. And the top, it just happens to work out that 1 cubed, right? So f of 1, we're going to plug back into f. 1 cubed is just 1, and then -1 cubed is still -1, but then we're going to subtract. Okay, so it actually happens to just also come out to 2. Okay, so that equals 1. Okay, so that takes care of this part of the equation. And now f prime of c. So that just means take a derivative and plug in c. So f prime would normally be 3x squared. So we're just going to say 3c squared. And now solve, right? So find the value of the constant c. So now we're going to divide by 3. C squared equals a third. And we're going to take a square root, and just be careful when you take a square root, there are two solutions, right? Plus and minus. Sometimes, like if this is multiple choice, they will just leave the answer choices like this unrationalized, but you should know how to rationalize still. So remember, you break up the root, but of course the square root of 1 is just 1. And then you multiply by root 3 over root 3. And then just put the plus minus back in. So this would be, this is rationalized. Sometimes they'll put the answer choice that way, sometimes they won't bother. And that's your answer. Okay, so what you have found are the places where the tangent line is equal to the average rate of change. So let me show you what that looks like. Okay, this is x cubed. We all know that, from pre-calculus. You remember x cubed, hopefully. So here's, this red line, that's x cubed. And this point right here is root 3 over 3. And this point right here is negative root 3 over 3. And you can see that the tangent line at that point is equal to, here's -1, here's 1, right? The average rate of change is that dotted line. And we can see those are all parallel. And so there could be more than one value of c. And that's really it. For us, most of the time, this is the kind of question you're going to answer. The only thing that would be different, obviously, is they could change the function or the interval. But you're pretty much just going to be doing this. Okay, so if you'd like to try 2 more, you could try this one by yourself, or you can watch me go through it, which I will do in one moment. All right, so again, I will start by writing this down because it reminds me what I need to do. I will go to the side. I will do f of 3 minus f of -3 all over 3 minus -3, which is 6. F of 3, let's see, that's 27 plus 20. That will be 47. And -3 is -37. And we're subtracting, so just be careful with the double negative. Sometimes you get 84 over 6, which is 14. And that takes care of that part. And then f prime, okay, well, we know the derivative is 3x squared plus 5, so we're just going to write 3c squared plus 5. And now solve for c. So, right, take away 5. 3c squared equals 9. Oh, this works out pretty well. C squared equals 3. And when you take a square root, just remember there's 2 solutions. And you're done. Certainly you do not need to graph it, but a way to check your answer would be to graph the function. So graph, x cubed plus 5x plus 5 on the interval from -3 to 3. Find the slope of the line connecting the 2 points, and then check, here's negative root 3, here's positive root 3. And sure enough, you can see that tangent line is parallel, and this tangent line is also parallel. And we're done. One more example for practice. Okay, would be this one. Same thing, I will go through it in a moment. Okay. So first take my derivative, doesn't matter what order you do it in, and then I'll also plug in f of 2 minus f of negative 2. It doesn't have to be symmetric, by the way. It doesn't have to be 2 and negative 2 or 3 and negative 3. It could be any numbers. Okay, so that's 4, and then f of 2 is going to be 4 plus 6 minus 9, and negative 2 would be 4 minus 1 is 3 minus 6 is negative 3. And so you get 12 over 4 equals 3. And so now set those equal, right? So f prime of c, it's f of b minus f of a over b minus a. So this just says take this and set them equal to each other. And so you can see that c will be 0. And you're done. That's it. It's really just the same steps every single time. Okay, and just to show you what the picture would look like, okay, this is the original function, the quadratic. Here's the tangent line. We found c right here at 0. And then here's the average rate of change connecting the two endpoints from 2 to negative 2. Okay, and we can see they're parallel. So the one thing that would matter is whether it's differentiable or not. And so here's an example of something that does not work with the mean value theorem. Okay, if we go back to the original statement of the theorem, back here, we said it had to be differentiable on the open interval. Okay, but very obviously this is not because, right, of the cusp at 0. This is non-differentiable. And so let's say you wanted to do absolute value of x on the interval from negative 2 to 2. Well, from the picture, you can see that that average rate of change would be 0. Okay, but there is no place, like if you draw your tangent lines, these are all just negative 1, negative 1, negative 1, right? These are all positive 1, positive 1. Okay, there's no place where you get a tangent line that's equal to 0. Okay, whereas if this were smooth, that would have to happen. Right? You would get a tangent line right here. So if it's not differentiable, the mean value theorem is no longer valid. It's no longer guaranteed. That's probably not something that's going to happen for us, very often, but it's just something we need to be aware of. Okay, so to summarize, this is the process. Okay, first thing you do when you're solving something with the mean value theorem is you just make sure it's differentiable. So no asymptotes, no holes, no gaps, no funny business, no cusps. All right, as long as it is, then you go ahead and compute f of b minus f of a, you find your derivative, and then you set them equal and solve. And usually it's going to be like a quadratic or something. You could get two answers, you don't have to. And obviously you only want to find answers in the interval that they give you. And that's it. So if you have any questions, feel free to shoot me an email or talk to me in class. Otherwise, have a great day.